Okay, good morning, everybody. So I've gone ahead and remembered to start recording this. One thing I realized that I forgot to cover as part of the testing lesson yesterday was what happens if we expect an exception. I said, so sometimes we're going to expect that an exception will occur. So in the example here, like if we try to set the count for um, for our class, for our course here. So we have this course class. The count is how many students can be in the course. And I'm assuming everyone can hear me, by the way, so just let me know if that's not true. But so we have the set count. And what happens if they try to put in a negative number, right? So here, the way that I've set this one is that if the count is, if the value they pass is greater than 0, great. We'll set it to that new value and everything is fine. Otherwise, we're going to throw this new invalid count exception. Okay, it's a personalized exception that I've created. Okay. So, but the question then is, okay, so we can test if we can change the count. So if I change this back to 50 each. So here I'm creating a new course with a class size of 120, and then I want to change it to 50, and I want to make sure that the new value matches the expected value. All right. So if we compile this and we run our test cases, we pass. Okay, this add course was the failure that we expected to fail, the one where I've reset the code back to the bad version. So basically the university get course is not the correct version of what we want. Okay, if you go back and watch the video from yesterday, or if you were here yesterday, you know why this is the wrong version, why this doesn't do what we expect it to, and a solution on how to fix it, on how to make it right. Okay, but for our other test, for the set count, right, it passes, right? So which we expect. Okay, so what happens if we want to test? Now we want to test to make sure that if somebody tries to put in a negative value, right, that it should generate an exception, right? But one of the things we talked about yesterday was these test cases. The way that it understands a failure to happen is if an exception, if the assert statement generates an exception, it doesn't know whether or not the exception was generated specifically by this statement or if an exception was generated by some other statement. The only thing that the test case knows when we run it is that an exception happened. And if an exception happens, then what we're going to see here is that here it failed. It failed the test case. But in actuality, it failed because this line generated our exceptions. So see here, this invalid count exception. So in actuality, this test case passed. In actuality, this test case did exactly what it was supposed to do. Sorry, not the test case. The code did exactly what it was supposed to do. This line generated an exception, which is what we wanted it to do. This line was never seen, but when we run the test cases, what happens is right here in the set count method, all that our test suite, all that our test runner knows is that an exception happened, and therefore must be a failed test case. So what we need to do is we need to test for an exception. Okay, so how can we do that? Well, what's going to happen? How can we test that an exception occurred? Well, what we want to do is we want to catch that exception, right? What we want to do is we want an exception to happen, but we don't want the test case to generate the exception. All right. So what we can do is we can say, we can put our set count method inside of a try block. Okay. So now what's going to happen? if an exception happens from this line, which is what we want to happen, then we can catch that exception, right? So we're going to catch, and we want to make sure we catch the right exception. Invalid count exception EX. Okay. So what do we want to have happen if our exception is caught? We want nothing to happen, right? We want it to see this as a passed test case, right? So now, if we do this, compile it and run it, now we have a passed test case, okay? But we're not quite done yet. Why? Because this code, this test case will always pass. There is no way that this test case could fail, right? So even if we come back into course, for example, and if we took this and we commented it out, right? So now no exception gets generated. We run it, we compile it, we run it. Oh, sorry, we just gotta wait till it's done compiling. Okay, we run it, and look, it still passes, even though it doesn't do what we're expecting it to do. So what we need to do is we need to generate an exception if this line does not produce one, right? So what we're going to do is we're going to say, okay, if this line produces an invalid count exception, we want to catch it and we want to do nothing. If somehow this line does not generate an invalid count exception, right? If somehow it generates something else instead, or if it just doesn't do anything, if it's just like in the case of where we're at right now, right? It doesn't do anything. It just sets the count if it's greater than 0, and otherwise it just leaves count alone. That's not right. So what we can do is we can either throw a new exception, or we can use a better methodology of assert equals. Okay, and we're going to give ourselves a message. We're going to say invalid count exception not thrown. Okay, so the message will be if this thing does not generate an invalid count exception, okay, we are going to tell our tester that exception wasn't thrown, right, as we expected. So what we want to do is we want to force this to happen. We want to force this to assert. So what we're going to do is we're going to say 0 equals 1. All right. So this is an assert that will always be false to 1. Okay. We could also say something like, we could also do true, false, right? Where true will never equal false. We could do any value here, knowing that it doesn't equal it here. Okay. So you can either do 0, 1, true, false, anything like that. Okay. So now when we compile this and we run it, okay, now our set count failed because it did not throw that invalid count exception. Okay. So now if we go back and fix our code over here, we say I want to throw that invalid count exception. We do this and we run our test case. Now it should pass because the invalid count exception was thrown now. All right, and we caught it. Okay. There is one problem with this, and I'm going to leave this as an exercise for you guys to kind of think about and do yourself, is what happens if we just throw exception? What happens if our code is we want to throw the invalid count exception, right? But our programmer did not do things right. They didn't follow the requirements, and they just throw an exception instead. So that should be fine. It should compile. Oh wait, sorry, unreport. I can do it with a runtime actually. Yeah, okay. So he throws a runtime exception. right? So we compile this. This is fine. This should run. And right. Okay. So again, right. So again, this through the new runtime exception, and the reason why it got a failed test case is because here we generated an exception that we didn't catch. The only difference here is that instead of getting this message, right, we end up not getting a special message. We don't get to know exactly what happened. We just know that something went wrong in the set count method. Okay, in the testing of the set count method. Okay, so maybe I'll leave this as an exercise for you to think about and consider. How can I check to make sure that the correct exception was thrown? All right, so let me go ahead and send this back to the way it was before. Make sure that it compiles, make sure that this compiles and executes appropriately. And good, set count now passes. All right. All right. All right, so that concludes our testing information. Before I move on, let me go back to the chat over here and just see does anyone have any questions about testing before we move on to abstract classes? Okay, I'll take the lack of chat and other comments as assuming that both that you have no questions and that you guys can hear me. So let's move back to abstract classes. Okay, so we'll introduce abstract classes here. So this was originally the plan was this would be the last set of lectures that we would have before the midterm. I'm not sure. We haven't reached a final decision about what the plan is for how to do a midterm at this point. So let me share the screen here. All right. Okay. All right, so this was the last set of lectures before the midterm was planned. So now I don't know what the plan is for a midterm or how we're going to do that. But I'm sure that you guys, as well as we will learn about the same time when a decision is made concerning that. Okay. So one of the nice things about object-oriented programming, about Java, is that we can have access to this thing called an abstract class, and we'll also talk about interfaces in this lecture as well. So the idea is, what if we want to define a class that kind of has some general ideas, some general similarities for all of its children? Right, so it's going to be a parent class, just like we've talked about parent classes before. We've talked about like you could have the student is a parent to a grad student, where a grad student is a type of student. We talked about that an employee is a type of person, so you can have like a person class defined, that all people will have some similarities, some common things, but then you can have an employee that has some special methods and special attributes in addition to the normal person. All right, and so what if we wanted to define this parent class, but we didn't want anybody to be able to create the parent itself? We don't want to create an object from the parent class. We want them to, if they're going to create anything of that type, of the parent type, they have to create one of the children. Okay, they have to remember the special word that we use is instantiate, right? So what we're going to do is we're going to call that an abstract class. Now, the word abstract, when we use it in terms like of language concepts or in terms of art, abstract just kind of means kind of less defined, right? An abstract concept is a less defined concept. And in the same way, that's kind of what it means here. So if we look here at an example, we have a geometric object. We're going to call that an abstract. It's less defined than a circle or a rectangle. So a circle, a rectangle, we know what those are, right? A circle is a type of geometric object. A rectangle is a type of geometric object. All right, we know that a circle has things like a radius, a circumference, a diameter. They both have area, both circle and rectangle have area, but a rectangle is a different type of object, right? It has a width and a height. It has, instead of a circumference, they call it a perimeter, right? It has angles, to 4 right angles, that kind of stuff. They are both types of geometric objects, but they're different. So what we might do is we might say, okay, well, all geometric objects have some things in common, but we don't want someone to create a geometric object on its own, right? We don't want somebody to be able to create this generic geometric object idea, right? And instead, we want to make them, if they're going to create a type of object, a type of geometric object, they have to create one of the children. They have to make a circle or a rectangle, or if we have a triangle, a square, and hexagon, all these other things out here as well. Okay, but there are some attributes and methods that all geometric objects will share. So they may all have a color. They all may have a filled attribute, whether or not it's filled in. There's the get color, set color, is filled, set filled. A two-string method we can define here. Now, I want to get to these two here, the get area and get perimeter. Now, these would be abstract methods because they're italicized, they're in italics. So one thing, I'll go back for a second here. Notice that the name here, the geometric object name, it's in italics. The circle, rectangle, not in italics. Right. So what that means is when we see an italicized, a name in italics, it means that this class is abstract, meaning we cannot create an object of this type. Okay. This is what we would call, instead of abstract, the other word is concrete. Okay. Non-abstract, we might also call it concrete. Okay, so a circle and a rectangle are both examples of concrete classes, meaning we can create an object of that type. Abstract methods, they're in italicized, they're in italics. That means that we can create an abstract method. Okay, I think that this would be where I would talk to any of my C programmers. If anybody in the class has a C background, this would be similar to if we had function headers at the top of our code. Okay, so what an abstract method is we're saying we want all geometric objects to have this method, but we don't want to define it here in the geometric object class. We want each class, each concrete class on its own to define these methods, right? Because they're different. The area method for a circle is different than the get area method for a rectangle is different than a get area method for another type of object like a triangle or a square, right? The get perimeter, same thing. It's a different method based on what our concrete class is. But we want to force our programmer to make that method happen. Okay? We want it to be there. We want all geometric objects to have it, but we want it to be defined here. And so we want to force our programmer to define that method in the circle or the rectangle class. And if they don't write this method, when they go to compile a circle class, if it doesn't have a get area method defined, when they go to compile it, they will get a compiler error. They will get a compiler error saying you have not defined this particular abstract method. Okay. Now, an abstract method cannot exist in a non-abstract class, in a concrete class. Okay, so in other words, we could not put an abstract method here in the circle class. Okay, all the methods in the circle class have to be concrete. An abstract class, on the other hand, can have a mixture. It doesn't have to have any abstract methods, but it can. It can have concrete methods also. It can have non-abstract methods. Okay, all right. So if and this is what I said before, of a subclass of an abstract superclass. So if a child that has an abstract parent does not create all of the abstract methods, right? The subclass, the child, must be defined abstract also. All right. So if we create a concrete class whose parent is an abstract class, then we must create all of the abstract methods. Okay. All right. Again, let me delete that. You can see that better. Okay. An abstract class cannot be created, cannot be instantiated using the new operator. You can still define constructors, so we still can have a constructor. And if we go back and look at geometric object, right, there are two constructors defined, right? Two constructors defined for geometric object. So we can have constructors, right, which are invoked automatically in the constructors of its subclasses if we don't specifically write them, right? If we don't call the super keyword on its own, then the super keyword is there by default. All right, we talked about that, the super no argument constructor, right? Okay, so automatically in the circle class and the rectangle class, the super keyword is used for the geometric object to call the geometric object constructor if they are not written explicitly for the circle class and the rectangle class. Okay. Again, as I said before, an abstract class can have non-abstract methods, right? So you can have an abstract class that doesn't have any abstract methods, and that's okay. All right. You still cannot create any instances of that class. We cannot create objects from that class, right? But it can be used kind of as the basis for defining all the other subclasses that we want to create. Okay. One of the things I'm going to do here, by the way, is talking about how inheritance can work. Is I plan to kind of have the drawing, kind of like we did with the testing video, with where I'll draw it on a whiteboard type of thing, because what I want you to understand here is pretty much any parent-child relationship can exist. Okay, you can have an abstract class that has an abstract child. You can have an abstract class that has a concrete child. You can have a concrete parent that has an abstract child. You can have a concrete parent that has a concrete child. All four possibilities exist. All right. So an example of a concrete parent that has an abstract child is our geometric object example. It's abstract, but its parent, if we don't have a parent explicitly defined, its parent is the object class. And the object class is concrete, right? But it can have abstract children. That's okay. There's nothing wrong with that. Okay. All right, moving on. As far as methods are concerned, right, we can have a concrete method existing in a parent class that then the child is abstract, and we can override the parent method to be abstract. Okay. Generally, we don't do that a lot, but it is possible. There's nothing wrong with that, for us to override a parent method to be abstract. Again, the only thing an abstract method does is it forces all children to implement that method. Okay. All right. Again, we we cannot create an instance from the abstract class using the new operator, right? But we can use it as a data type. So here we could have an array of geometric objects. Now remember, geometric object is abstract, so we cannot create an explicit object of geometric object, but we can create an array to hold geometric goes in there is going to be a circle or a rectangle or something else concrete. Right? So we can say this array can have a mixture of different geometric objects. They all need to be a child of geometric object, right? But we can put in a mixture of things. That way we can put in, for example, in your assignment, right? Your assignment 2. If we wanted to say we wanted to have an array of a mixture of products, right? But we wanted product to be abstract, but we wanted all of its children, its food product, its clothing product, stuff like that. We wanted all of its children to be concrete. We could still have one array list that would be like the inventory array list or array. That would be all of the product types, but we just put the different specific products in there. Okay. So another example of an abstract class that we've used, that we've talked about, is these wrapper classes. So they all inherit from the abstract number class, but all of these other specific types, right, will inherit from there. So these are concrete, double, float, long, integer. All these are concrete classes that all inherit from the number class, the abstract number class. Right. And notice that some of their methods, some of the number methods here, int value, long value, float value, double value, are all abstract methods, which what that means is that the creator of the number class said, I want every child to have some version of this method inside of it, right? But I don't want to define it here because I want it to be defined here. Okay, and it's forced. Whoever implemented these right here, whoever implemented these concrete classes had to create that. Okay, another example, the calendar class is an abstract class, and then there's different types of calendars. Okay, I won't talk too much about that. All right, I won't talk too much about the calendar, but there are some additional slides for you to look through. Okay, and we won't get into interfaces today. What we'll do instead is we'll look at a couple of examples. Okay, we'll look at a couple of examples of, let's see, let me go move into, all right, our abstract class example. Okay, so here if we open up geometric object, now the way that we define, actually let me take a step back and just make sure, let me go check out the conversation to see, does anyone have any questions before we look into the example? Nope. Okay. Hold on a second, I got one thing. Okay, so what we'll do is we'll pull up some examples here in just a second. Okay, so let's see. Let me share this guy. All right. So the way that we would say that a class is abstract is we just use the abstract keyword. So before the word class, we say abstract. So what happens is now we can have abstract methods inside of this class. So here, the geometric object class, there are certain things that are going to be available to all geometric objects. So we'll have some variables here, some attributes, right? We'll have some constructors, right? A default geometric object, a geometric object that has a couple of parameters that we pass it. Right, and so then we'll have some methods that'll be the same for all geometric objects. So the get color, set color, is filled, set filled, these are all going to be the same for all geometric objects. Get date, the toString method. Okay, now one thing I want to point out is that even though these methods exist in geometric object, there's nothing that stops us from overriding them in the child class. Okay, just like we've done before, just like we've talked about before we talked about abstract classes, when we talked about inheritance, right? We have a method here, for example, the set color method. We can change that in its child class. We could change that in the circle class to override it. Okay, there's nothing that stops us from doing that. But if we don't, then what's going to happen is the circle just gets access to this method instead. Okay. In the same way that we made a class abstract by using the abstract keyword, we make a method abstract by using the abstract keyword. So here, public, before we give the type, right, the return type of a method, we state it's abstract. We end it with a semicolon, right? We end it with a semicolon, that's syntax. If we don't, then we get a compiler error, just like any other line of code that would be missing a semicolon. Okay, so if we don't do that, then we say, oh, we expected a semicolon, but you didn't give it to me. Okay. Okay. Now, if we don't use the abstract keyword on a semicolon like this, and we try to compile it, all right, we get a compiler error here. All right. There's no method body, or you need to declare it abstract. Okay. We cannot give a method body. Okay. We cannot give a method body to an abstract method. So if I try to give a method body to this, okay, it's going to tell me abstract methods can't have a body. Okay, so and what we're saying is we're saying by definition, an abstract method is one that we want to exist in all children, but we do not want to define it here. So if we try to define it here, then it's saying, well, how can you define a method that you're saying I don't want to define it, right? So you have to have no method body for an abstract method. All right, if it has a body, it's concrete. If it doesn't have a body, it must be declared abstract. Okay. All right, so this is this is how we would define some of the abstract methods in an abstract class. So let's take a look at a circle. Okay, so a circle is, let me this looks like it hasn't been saved and compiled. Okay, good. So here a circle extends geometric object. This is no different from before. A circle is the child, geometric object is the parent. Okay, it's the same as before. The only difference now is that geometric object has some parent stuff. It has some abstract stuff in it. Okay, now notice that here we've overridden the get area and the get perimeter methods. Okay, if we don't, so if we compile this, right, it should compile just fine. All right, so it compiles fine. If we don't override this method, if I take this, for example, and I comment it out, okay, so now get area is not implemented. Get area does not appear in the circle class, but if I try to compile this, what's going to happen is the compiler is going to look into the parent. The compiler is going to see, hey, there's an abstract method here called get area, and it has to be implemented. You have to create this method. So if I try to compile this, it's going to tell me, hey, Circle's not abstract, right? And in its parent, let me move this out the way so you can see this. Okay, in its parent, right, there's an abstract method called getArea, and you didn't implement it. You did not make that method happen. So you have to make this method happen. Okay. Now it doesn't matter what this is. This could be, instead of returning this value, you could be just return 0, right? And this will compile and run just fine, right? Because even though this is incorrect, even though this is now not a compiler or runtime error anymore, this is now a logical error, right? This is the code not doing what it should do, right? So if we go back, getArea is now implemented and it's there. Okay. One other thing, we cannot have an abstract method inside of a concrete class. Okay. If we try to put in a method here, just make it a void method, an abstract void method do nothing. Okay. If we try to put an abstract method inside of a non-abstract class, if we go to try to compile this, it's going to tell me circle is not abstract and does not override abstract method do nothing in circle. So basically what it's saying is, you have an abstract method defined in a non-abstract class, you can't do that. Okay. Now, could we make circle abstract? Now it compiles. Yeah, it compiles just fine. But now we have a different kind of problem. We cannot create a circle now, right? If we go to the test geometric object, right? If we try to compile this, right? Circle is abstract, and I'm not allowed to create a new circle. So that's going to be a problem. So we want to make circle not abstract, and we want to take this method out because it has no business being there. So now we create a circle, geometric objects, happy. Okay. So the last thing we'll do today is we'll run through this code so that you can see how this works, okay? Because there's a few things here as I want to point out. Notice that the variable here, we didn't call it a circle, we called it a geometric object. And the reason why is because we want this variable to be able to hold any type of geometric object. Now, geometric object, the class, is abstract, which means we cannot create an object using the new keyword of it, right? But there is no problem, none at all, with assigning a variable of this type and then creating a child, a concrete child of that type to that variable. Okay. So here, when we run this using debugger, okay, we're going to create a variable called geometric object that it's going to hold a circle type. So notice it's a geometric object variable that points to a circle. The circle is a type of geometric object. It extends from geometric object. Same thing with the rectangle. Okay. Now, this equal area method exists inside of our local test geometric object class, right? It takes two geometric objects and it just tells us do the two getArea methods return the same value. Okay, so if we step inside that method, notice our object 1 is our circle, our object 2 is our rectangle. Does a circle with radius 5 have the same area as a rectangle with radius 3? Does Does a circle with a radius 5 have the same area as a rectangle that's 5 by 3? I think not, right? So we step in, okay? Our circle is going to its area, right? And do the two objects have the same area? The answer is no. All right. So what is display geometric object? It's going to display the area and the perimeter of the two. Right. So our first time we pass it, our circle. All right. The second time we call this method with geometric object 2, what we're going to do is we're going to pass it instead the rectangle this time. This is really nice, okay? This is really nice for us to be able to not have to define a display, the geometric object for a rectangle method for displaying a circle, then having a different method for displaying a triangle. Here we can have one method that displays a geometric object and we can pass it a circle, we can pass it a rectangle, and there's no problem with that. So this is a really nice tool for us to be able to use, right? Okay. And then, so one of the things that we will get into in the future, so we'll end specifically our discussion there. Okay. One of the things that we'll get into in the future, and I can go ahead and let you guys see me, I guess, here. One of the things that we'll get into in the future is with the interfaces is, so in our example there with where we compared the areas of the two, we had a local method inside of our test class to do that. But what's going to be nice is we're going to be able to use interfaces or the parent class itself. We're going to use different ways to be able to have it do it on its own. So just like our string class has the equals method, we can do that same thing inside of a class that has children, or we can do that using the comparable interface when we talk about the interfaces, and we'll get into that next week. Okay. All right. So does anybody have any questions before we end this meeting? Nope. Okay, well, thank you guys for joining us again. And this video should be uploaded to the stream, and to then after it gets uploaded to the stream, I will post it to that YouTube channel also, and you'll be able to see it there. Okay, so just if you weren't able to join us today, then hopefully you'll watch this on one of the streaming services. All right, thanks guys. And this ends our time today.